Now, this illustration further deals with phase arrangement in accordance with NEC 408.3E. And the note says color coding is no longer required by the NEC, but may be used for phase arrangement, is outlined, say, in your 310.10A through C for conductors, insulation around these conductors. Now, color coding kind of went out in the 75 code. And it's the grounded neutral conductor. If it's white or gray, well, that usually represented a 120, 208, 120, 240, 120 volt system. If the white or gray neutral had a color tracer in it, then that represented 277, 480. And then in the recent edition of the NEC, they said, no, you could use white for 120, 208, 120, 240, or 120. And then you would use gray, if you wanted to, for 277, 480. But the color coding scheme that you see in the boxed in information is recommended. Some states, counties, and cities still require a 120 208 volt system to be black, red, blue. L1, L2, L3, say, or your phase A, B, and C. However, they are identifying it by their ordinance. The 277 480 would be the boy system. Brown, orange, and yellow. Brown for A, orange for B, and yellow for C. And then usually there's a white neutral with a 120 208 and a gray neutral with a 277 480 that you'd see. And then sometimes the city will let you, or state, county, or city, let me make that clear, will allow you to take all conductors black, number 4 and larger, and they would allow you to spray one conductor, say black, spray one red, spray one blue, a spray that wouldn't affect the insulation, or tape it. And they let you tape it instead of having to buy a conductor that would have solid black insulation, solid red, and solid blue. They let you identify. Now, we know that our 310.10A refers you to 200.6 for the grounded conductor or neutral. 310.10B refers you to 250.119 for the equipment ground, which could be green with one or more yellow stripes, or strip where it appears in the system for certain size conductors. And then C would basically say for the ungrounded phase conductors, you could not use white or gray, green, or green with a yellow stripe. Now, if we reviewed 210.6, that deals with insulation and where you could use the insulation of a conductor. Like W, for example, that is listed and identified for wet locations. And then you would have, say, THHN that could be used for dry or damp location. All that information is found in 310.6. Now, as an electrician, 310.10 and 310.6, along with table 310.4A in the 2020 edition of the NEC, are three main sections, two sections in a table that you must know as an electrician, so that you select based upon insulation and the color coding or identification of your conductors, how to terminate those at 60, 75 degrees C. Now, we'll get into a lot more of derating and correction factors and adjustment factors when we get into Chapter 8. But notice that the two bars, if you have the two bars as you see, you could isolate that neutral bar, take the grounded bar and ground it to the enclosure and connect it to earth ground. And then you could bring your phases in there, A, B, and C, and terminate those. The B phase would be the high leg, and the panel is usually in other words, the panel board has to be listed for that type of connection and hookup in accordance with 110.3, B as in boy and C as in car. Or the authority having jurisdiction would tell you how a high-lead system would have to be installed to comply with code. For example, sometimes they will bring the delta voltage into an auxiliary gutter and then tap, as we previously stated in Chapter 6, for 122 40-volt single-phase panel. And then in the three-phase panel, they would have the high leg, and that way electricians would not make a mistake. Because if you have it as shown in the illustration, you can't get on phase B and feed 120-volt systems. You have to stay with A and C phases, or L1 and L3, to be able to obtain your 120 volts to ground. So that's what this figure 7-5, along with section 408.3E, is illustrating the phase arrangement in equipment. Depending upon, is the grounded conductor or neutral present?